All right, in this little mini lecture, we're going to talk about enzymes. So here it says, what the enzyme told his substrate, you complete me. All right. So enzymes, what we know about enzymes so far is that enzymes are types of proteins. So in blue is our little enzyme, and in pinky red is our substrate. And what I want you to notice is kind of like the shape of that substrate and the shape of the enzyme, that it looks like they fit together, right? So one goes over to the other and they kind of hold each other tight. So that's why he's saying, you complete me. So why does this all happen? All right. So we know enzymes are what we call catalytic proteins. They are catalysts. They help to speed things up. And they do this by changing the rate of the reaction. So in the presence of a protein, a reaction can occur much more quickly. So I can have, let's say, a glass of water and I put a sugar cube in there. And if I don't stir it and I don't heat up that glass of water with the sugar cube in it, over time the sugar will eventually dissolve, right? If I stir it, it'll dissolve much more quickly, right? But I'm kind of adding energy to it by stirring it. And if I heat up the water and have the sugar cube in it, I'm still adding energy to the system and it will dissolve quickly. But what if I don't add any energy at all and I just allow that sugar cube to sit in that water? It will dissolve, but it's going to take a long time for that to happen. So without adding any kind of energy to the system, what if I add an enzyme? If I add an enzyme, then the sugar cube will dissolve much more quickly than if there were no enzyme. All right, so an enzyme can change the rate of a reaction that happens. And then it says that it's not consumed by the reaction. So our enzyme's not going to be changed at all by the reaction. It can do that chemical reaction over and over and over again, time and time again. All right, so it's not going to be chemically changed at all. It can still accept the same reactant molecules and convert them to product. All right, so typically, enzymes are named after the reaction they catalyze. So later on in the semester, you'll become familiar with DNA polymerase. So this is an enzyme that helps to make DNA polymers or DNA molecules. Um, in the example above where I said we could add an enzyme to our glass of water with sugar in it, we could add the enzyme sucrase. So sucrase helps to break down sugar, which is sucrose. So sucrase works on sucrose. And if you'll notice, there's kind of this ASE ending to our enzyme. So that's kind of one way that you can recognize enzymes is by that ASE ending. So I have here the example of polymerase. I was just talking about DNA polymerase, so the ASE on the end. Later on, we'll talk about this reaction here where we have carbon dioxide and ribulose biphosphate. These two molecules are going to be converted to this phosphoglycerate molecule, and we're going to use this enzyme to do it. It's called ribulose biphosphate carboxylase, and that's actually also oxygenase, but there's the ACE ending there. So some of them can get very long. And sometimes we give them an alternative name that's a little shorter. So ribulose biphosphate carboxylase is called Ribisco. So there's no AS ending on Ribisco, but its real true name does have that ASE ending to it. And it's named after the molecule that it works on. So it works on this ribulose biphosphate molecule. So we name the enzyme after that molecule and add the ASE ending to it. Now, for a chemical reaction, we typically have what we call reactants and products. So the reactants are kind of what's coming together, what we might be joining together to make a product, what is basically produced at the end of a chemical reaction. We could have one reactant molecule that is then split into two products. We could have a couple of reactant molecules that are combined together into one product. It all varies, right? In a chemical reaction, the reactants are what we call substrates. So over here, this kind of dimply looking structure is our protein, our enzyme, and you notice it has a little hole in here. This is what we call the active site, and the active site is where our substrates will come in and bind to the enzyme. And just like in that original cartoon, the shape of the active site should mimic the shape of our substrates. Right? The two of them have to kind of fit together nicely. So once the substrate comes in and binds to the active site, we see that the enzyme changes its shape a little bit. So notice now it's kind of almost hugging the substrate there. And this is what we call induced fit. This is when the enzyme changes its shape just a little bit so that there's a very nice connection. There's good bonding that is happening between our substrates and our enzyme within the active site. So the active site is just one small area of the enzyme. Okay. Now, this active site allows the substrate to be converted to product, right? We said that enzymes help to catalyze reaction. They help to speed reactions up. So we're creating a nice little microenvironment where the substrates are coming in and they're making contact with each other so that we can form different bonds. And then the substrate gets released from the enzyme. So instead of having these two separate molecules here, it comes out as one molecule, right? So we've converted from substrate to our product. So from having two substrates to one product where they've been fused together. Now notice the circle goes around. Our enzyme is now available and has a free active site so that it can accept new substrate molecules. They come into the active site. We have induced fit where it makes that nice snug configuration and it converts it to product. I kind of like to think of an enzyme like as a judge. So two people might come before the judge, right? Two people might come before the judge. Our judge is right here, our enzyme, and the judge can join them in matrimony and sign off on their marriage license. And when they leave the courthouse, they are now a couple. All right. Now, what happens to the judge? The judge is ready to perform the next marriage ceremony, right? He's not changed by it at all. The next two people come in, right? Comes before him, joins them in matrimony, and then they leave, and the enzyme can go back around and do the same thing. Now we could go in reverse, right? We could take the couple, go before the judge, and he signs a divorce decree, and now the two people go their separate ways. All right. So that's what enzymes do, right? They help to catalyze reactions, help things to proceed much more quickly, and they are not changed by the reaction at all. So here's a question for you. So we have a chemical reaction here where sucrose, right? We were just talking about having a sugar cube, and that is sucrose. And sucrose gets converted into the two monosaccharides of glucose and fructose. In other words, sucrose is broken down, the disaccharide sucrose is broken down into the two monosaccharides of glucose and fructose. So question 1 asks you, what is the substrate? Identify the substrate in this chemical reaction. Okay. Then to identify the product, what is being made. And last, identify the enzyme that is involved. So our substrate is sucrose. So this is number 1. So number 1 is our substrate. The substrate is going to come in and bind to our enzyme. Our enzyme is sucrase. It has that ASE ending on it. Oops, that should be a 3. All right. So Sucrase is the enzyme. And then glucose and fructose, both of them are the product. Okay, so sucrose gets broken down into a product of glucose and fructose, and that's being done with the assistance of our enzyme sucrase.